Bismillah ar-Rahman ar-Rahim. Good evening, guys. Today we will talk about the Ohm's law. We have two purposes today. The first one to verify Ohm's law. The second one to calculate the unknown resistance value. For example, I have this resistance. It's unknown. We don't know the value of this resistance. By using circuit like that and connecting all of these parts, all of these devices according to this diagram. Emitter connected, series connection. Here it's parallel connection that's related with them resistance. Here has less resistance because that if we connected it with parallel connection, that means we will produce a short circuit, some damage in our emitter, and we will lose the power of our battery. Because that, take a look, review the short circuit object. Here I have this key. I connected this bulb to take a look when increase the current and voltage, what will be to this bulb. Its power will increase or decrease. We will take a look. Here is the R state. It's a variable resistance values. Actually, we will depend on power supply or battery. That means DC electric power. DC electric power has one amount, one value of voltage. Here it's 6 volts, and for AH that means 4 ampere to hour. All I wanted to say, we have just specific value about voltage and current. By that, if I connected it and try to calculate the resistance from this part, from this unknown resistance part, we will have just one value of current and one value of voltmeter. But we will use this R state. It's a variable resistance value to increase and decrease the different potential and current to the same unknown resistance. To what? To verify Ohm's law. Okay? Let me start. Here, from here it's maximum. Here to this side it's minimum. My R state, the maximum value of resistance is 20 ohm, 2 ampere, according to this diagram. Here the R state, simple. Here it's power supply or battery. The key, my unknown resistance. We will try to calculate its value and the voltmeter. Bismillah. Here, let me start from 0.6 volts from this voltmeter. Let me from this 0 to 1 volt, I have 10 parts. That means each part equal 0.1 volts. By that, this 0.6 volt. Let me write that. 0.6 volts. And take a look to the emitter value. Here it's 0.12 ampere. After that, it goes like that. I will increase the different potential more, 0.2 to be 0.8. It's 0.8 volts equal equal 1.6 ampere. Let's increase the voltage to be 1 volt here. When I increase the R state, the bulb power is increased. Okay, let me change the electric power with bigger one. I used 3 parallel battery with 3 series connection batteries. Each one was 1.5 volt. That means approximately less than 4.5, because we consumed some power, electric power from this. And I will use 6 volts. Okay, let me use one of them. Solvable. Now, let's do that again. Now it's better. Okay. With 1 volt, the current is 0.2. 1 volt, 0.2. Now let's work on 1.2 volt. Take a look to the bulb power. When I increase the R state, it's increased. 1.2 volts equal 0.24. Now 1.4 volt equal 0.28. Here, some relation between these numbers. When I increase the voltage, the current is increased too, with, let me say, with a specific value. Okay, that has some meaning. Take a look to the bulb. Now the last reading will be 1.6. Let's try on 1.6. If I can calculate it or not. Okay, that's it. Now, if we calculate each number from these 5 numbers, we will have the same value. 0.6 from Ohm's law equal different potential divided on current. By using this form, if we calculate each number from this voltage with what was equal with current, we will have the same value, 5 ohm. Let's take a look to our resistance. Is that true? It was 5 ohm or not? Let me take a look here. Let me use my marker pen. It's actually equal 5 ohms. That's mean we verified the Ohm's law by using 5 or 6 readings and use directly the form. We found the unknown resistance value really equal 5 ohm by using the theoretical side. By using the Ohm's law directly, the experimental side will be plot the relation between current and different potential. The different potential will be at x-axis, current will be at y-axis. We will plot the relation between them. The relation between them is linear direct relation, and by calculating the slope, when slope equal from tan theta equal delta y divided on delta x, that's mean slope here will equal delta I divided on delta v. It's inverse the Ohm's law. By that we can conclude the resistance, unknown resistance value here, it's equal the inverse of the slope. Must be equal 5 ohms to be all of these two solutions parts are equal, the theoretical side and experimental side. Now our experimental is finished. See you in the next video.